Here we have honest pre-calculus problem. Okay, let's go with the question. If log 5 to the base 3 equals to 3y, log 4 to the base 3 equals to 2x, and log m square to the base 3 equals to 6, then log 100 times m to the fourth power to the base 3 is equivalent to. Okay, let's actually our aim is to find the value of this expression. Okay, let's use the properties of logarithm over here. So we have log to the base 3 100 times m to the fourth power. Here in the argument, we have two quantities multiplied, 100 m and m to the fourth power. So whenever two values are multiplied in the argument, we can use the product rule of logarithm. That is, we have to take this log 3 to each value and add them. That's a product rule. So we get log 100 to the base 3 positive log m to the fourth power to the base 3. And further, this 100 can be written as 10 square positive log to the base 3 m to the fourth power. So here in these two logarithms, the arguments are exponential. Whenever the argument is exponential, the exponent in the argument can be moved in front of the logarithm and it has to be multiplied by the logarithm. So this is a power rule of logarithm. So then I'll be getting 2 times log 10 to the base 3. And here this, if I move this exponent 4 in front of the logarithm, I'll be getting 4 times log m to the base 3. So log, this 10 can be written as 2 times 5 to the base 3 positive 4 times log m to the base 3. Here the argument, two values are in multiplication. We can take the logarithm for each value and we can add them. So that is the product rule of logarithm. Then I'll be getting 2 times log 2 to the base 3 positive log 5 to the base 3 positive 4 times log m to the base 3. Okay, now so we have to get the equivalent stuff for log 2 to the base 3, log 5 to the base 3, and log m to the base 3. Okay, so for log 5 to the base 3, already we have the stuff that is 3y is equal to log 5 to the base 3. And for log 2 to the base 3, I don't have. So, but we can write this 4 as 2 square and we can use a power of logarithm. And also for log m to the base 3, we can get it over here because we can use a power rule over here. Okay, first let me apply the power rule in this one. For that, what I need to do is I have to write this log, this 4 as 2 square equals to, on the right side we have 2x. And this 2 can be moved in front of the logarithm using power rule. Then I'm getting 2 log 2 to the base 3 equals to 2x. Okay, now I divide both sides by 2. Then I'll be 2 will cancel out. This 2 will cancel out. I get log 2 to the base 3 equals to x. Okay, now I got the stuff which is equal to log 2 to the base 3. And also, if I use the power rule over here, the exponent 2 can be moved in front of the logarithm. Then it will become 2 log m to the base 3 equals to 6. Now I divide both sides by 2. This 2 will cancel out. Then I get log m to the base 3 equals to 6 over 2 is 3. Okay, now I have the stuff which is equal to log 5 to the base 3, that is 3y. And for log 2 to the base 3, we have just x. And for log m to the base 3, we have 3. Okay, now we have to plug in all the stuff over here in this expression. Okay, let me do it on the next page. Okay, now we can plug in the stuff for log 2 to the base 3, log 5 to the base 3, and log m to the base 3. So for this log 5 to the base 3, already we have in the question itself, that is 3y. And for log 2 to the base 3 and for log m to the base 3, just now we got the equivalent stuff. Okay, now we can plug in. Okay, for log 2 to the base 3, we have x positive. For log 5 to the base 3, we have 3y positive 4 times. For log m to the base 3, we have 3. Okay, now I can distribute this 2 to x and 3y. Then I'll be getting 2x positive 6y positive 4 times 3 is 12. So this is an expression which is equivalent to log of 100 times m to the fourth power to the base 3. Okay, now we can move to the original question so that we can check the correct option. Here we have the given question. Okay, so we just got 2x positive 6y positive 12. This is the expression equivalent to this logarithmic expression. Okay, so actually when I look at the given options, they have taken y at first. So here if I write y at first, then I'll be getting 6y positive 2x positive 12. I find this expression in option B. So the correct answer choice for this question is option B.